Okay, so this is a re-recording of what I did on the first day of lecture. I'm not going to include my introduction, all of that stuff, because you watched the intro, so you have that. But I am going to start with what we did in terms of review. I'm going to break this down into a couple of pieces, and we'll talk about math setups for chemistry, problem-solving, test-taking, and scientific method first. Then we will talk about periodic table and trends, bonding types and names, then chemical reactions, concentrations, and stoichiometry, dissolution in water forces and properties, and then gases, acids, and bases, and precipitation reactions. So those are the bits you're going to get. That first bit is what I call the tips. So this is not specifically chemistry stuff, but it's stuff that I want to talk about in terms of what this class is about. Now, you'll notice during this lecture that there are links in the lecture. Those take you directly to sections in your textbook so that you can see what we are talking about. If you need something clarified from any of that, please let me know. Okay. So the first thing we're going to talk about is the factor label method. So you'll see that I have here written out a calculation where I have 25.368 grams of sodium hydroxide in 3.5 liters of water. I know that 1 mole of sodium hydroxide is 40 grams, so I divide by the molecular weight. I then know that there's 1 mole of HCl required to react with 1 mole of NaOH. And that's because of this balanced equation down here. There's 1 mole of NaOH plus 1 mole of HCl goes to 1 mole of NaCl plus 1 H2O. So I also know that I have a 0.026 mole per liter solution of HCl, and then I convert from liters to milliliters to get an answer in milliliters, okay? So all of these numbers have units on them. And the reason for that is that if I write this out, I have 25.368 grams of NaOH in 3.5 liters. I divide by 1 mole of NaOH, being 40 grams of NaOH. Those grams cancel. I now have moles of NaOH. I have 1 mole of HCl, or 1 mole of NaOH, from the stoichiometry of the equation. 1 mole of HCl is 0.026 moles of HCl in that per volume of that solution. So the liters cancel and milliliters cancel. And then 1,000 milliliters per liter. Okay. So I had molarity. And that will give me a volume of that solution that is needed to titrate that thing completely. Okay, so I can cancel all my units to make that work. And that's the way that I know if I have the right unit, I have the right calculation. So that's why I do what I do. So that's the factor portion. The other part of this is the train track part of it. So anything that's above the line, I'm going to be multiplying. Anything that's below the line, I'm going to divide. So it's 25.368 divided by 3.5 divided by 40 divided by 0.026 times 1,000. So that's how that works. So that's the math setup. Now, are you required to do that? Absolutely not. Is that the way I do it? Yes, every time. And you'll see me do these 1,000 milliliters to a liter every time too, because that's the way I handle it. That way I make sure that my units cancel and I don't have to think about things in my head. I'm not really good with things in my head. So another thing that I try to do is when I'm setting up problems to solve, I try and get all of my information out of the question that I've been asked. And the first thing I always do is say, okay, what am I dealing with? Can I write a balanced chemical equation for this? So if I'm looking at the reaction between HCl and NaOH to give me NaCl and water, I'm sorry. that's going to be NaOH plus HCl, going to give me NaCl plus H2O. Now, the cation here is Na plus. We have an OH minus, an H plus, and a Cl minus, going to an Na plus a Cl minus plus an H plus an OH minus. Okay. Now these have combined to make an H2O liquid, which we typically don't separate because it's a liquid, so they stay together, so they're not ionized. When we do this, this is a double displacement reaction. So the cation from the first species, the Na, goes with the anion from the second species, so the Cl minus from the HCl. Okay, so this Na plus here goes with the Cl minus there, and the H plus here goes with the OH minus there. So that's how we get our products on the other side. Now, I know that I have 25. I'm going to erase this part and this equation right here because that's how I got to it, but I don't need it right now, so I'm going to get rid of it because it messed up what I was trying to do. Awesome. I know that there's 25.368 grams of NaOH and 3.5 liters of solution. I know that this is a 0.026 molar solution, and I know that I'm looking for how much of that solution do I need to make this work. One of the other things that I did was to get the molecular weight per mole. Now, I tend to get it for everything, and there's a reason that I do that. There's a couple of reasons, actually. And let me just write these down because it's going to drive me crazy if I don't. And that's part of why I do this, because it drives me crazy if I don't. What I found when I was a student was that I learned to organize all of this information. And inevitably, if I looked up just the NaOH molecular weight, I would need one of the other ones. So I decided, in my infinite wisdom, to calculate them all, put them all down, and then if I didn't need them, that was fine. But it's a fairly short calculation for me to get them all. Okay, so that's what I do there. All right, so I know... Sorry, oh my God, I'm so sorry. That I have 25.368 grams of NaOH. I'm going to convert that to moles by dividing by the 40 grams of NaOH per liter. Sorry, 40 grams per 1 mole of NaOH. I get rid of my grams, that gives me the moles. I have 1 mole of NaOH to 1 mole of HCl, and that's from the balanced equation. Those are the stoichiometry. The numbers out in front of the NaOH and the HCl are both 1s. That's why it's a 1-to-1. I get rid of the moles of NaOH. I then have 1 mole of HCl, and I have the molarity is 0.026 moles of HCl per liter of HCl. So I can get rid of moles of HCl, and that leaves me with an answer in liters. But 1 liter is 1,000 milliliters. So I get rid of the liters, that leaves me with milliliters, and that gives me everything I need. Now, what that tells me is I didn't actually need to know what the volume was that this thing was dissolved into. And so 25.638 divided by 40 divided by 0.026 times 1,000, and that gives me 2,465 milliliters. And that's how much of that HCl solution I actually need. Okay, so this is a mistake. This does not belong here. And this should actually be 2,465. Yay, I love it when I make mistakes. And I apologize, so I'm correcting that on the fly. But that's what I do for consistency's sake. So I try to put everything in the same place every time. That way I know where my information is. And it helps me to organize it. Okay, So that's my technique for problem solving. I take that equation or that thing that I've been given and pull all that information out of it so I don't have to look at it again. Okay? That's why I have that question mark, because that's the answer that I'm looking for, is what is the volume of the HCl that I need to do this? Okay. Now, as far as test taking goes, I'm going to give you a couple of pointers in terms of test taking. These are not necessarily as applicable to my tests as they are to the final. Now, if you've been through 110, which you must have to get here, that means that you took the 110 final. And the 110 final and the 110 lab final both are designed so that they are too long to be taken in the time that you are given. That's meant to give you pressure. So you're supposed to figure out what are the things that I'm most able to answer in the time that I have available. And so the curve is supposed to reflect what people are able to answer in that time. Some of the things that you can do to help to get you the best position for doing that. First thing you want to look through, how long is a test? How many questions are there? What does that mean in terms of how much time can you spend on each question? And if it's a 2-hour test, which gives me 120 minutes, and there are 70 questions, then that means I get 1.7 minutes per question. Okay, so I know how much time that I have per question. Now, some of them will go faster, and I can use the extra time to work on other things, but getting that rough estimate of how much time you can spend on each question is helpful, because it keeps you on track, all right? Other things that you have to consider, though, is not every question is going to be worth the same amount of points, right? And some questions are going to have multiple parts to them, so that can be hard as well. What are other things about that? So are they all short answer? Do you have multiple guess? Do you have true false? Do we have problem solving? And it depends on who you are and what kind of test taker you are, what order you do those in. I tend to look at true false, then multiple guess, then short answer, then problem solving. Really, because that's the way that it tends to work best for me. I need time for problem solving. I don't need as much time for true false. Short answers are usually fairly quick to deal with. Multiple guess can be really big pains in the neck because they can be very particular in what the answers are for what you're looking at. Okay. And then look through each of the questions. If there are some that you know without having to think about it, just answer them and move on. Are there some that you have absolutely no idea about? Make a note. Go back to them when you're done with everything else. Remember that the number of minutes you have divided by the number of questions in the test is an average for what you're going to spend on each question. For multiple guess, one thing I'm going to tell you is that if it is a multiple guess, look through those answers to see what you can eliminate. Okay? If there's something wrong with that answer, get rid of it. Okay? And then choose the one that's the best fit. And then make sure that the answer that's reported is reasonable. Okay, so we did this calculation. We wanted to know how much of this solution that we needed. My answer was like 7.8 liters. That might have been a little excessive. Okay, so we want to make sure that that's reasonable. You'll catch me doing that sometimes when I'm in class. I'll be like, wait. And you'll see that I've made a mistake somewhere. I go fix it. And that's because I saw that something about that answer didn't sit right with me. Didn't pass my smell test. Okay, so there's that. On multiple guess questions, usually when he's writing them, he goes for the odd man out. Whatever is slightly different than the rest, that's the odd man out, and that's usually the one that works the best for those tests. Okay, so that's just some test taking stuff. I used to teach test taking techniques to people, so there's that. Now, this part is not as important to the people in the labs or the online labs because you're not physically in the lab. When you're physically in the lab, and the same is true when we give you labs to do in the online classes. We're not doing this simply to torture you. That's not what that's for. It's meant to illustrate what's going on in the laboratory, in the lecture, to show you what that looks like. And that means that we've set out to answer a specific question. We're trying to observe something. So there's something that we want to look at, and that's usually based on the information that we've been given in the lecture. So for instance, in the first lab that we do, the chemical equilibrium, we're looking at how much of this material have I formed at equilibrium? And based on those equilibrium concentrations, can I calculate the K for that reaction? Is that K consistent between all of the experiments that I do? And if not, why not? Going into that, we should have some idea what we're expecting. Some idea based on the information that we have. That may be right, that may be wrong. And it doesn't matter. It really does not matter if you're right or if you're wrong. You can test that, analyze your data, and see if it supports it. And if it doesn't, that's okay. Okay? A negative result is just as good as a positive result. And I will tell you honestly, very honestly, getting an answer that does not support what you thought it was going to be requires you to understand it a lot better than if it does support what you thought it was going to be. Because if it goes right along with what you thought it was going to be, we don't think about it very much. If it doesn't, then that's when we start looking at it to say, okay, what exactly is happening here? How do I change this? How do I tweak it? What is it that I need to do? One of the things I need you to be able to do at this point is to be able to look at the laboratory that you're doing and say, okay, critically, not to be mean to yourself, not to be judgmental of whoever did it, nothing like that, but critically looking at that experiment, what are things that might have influenced what you see? So one of the things that we can talk about in terms of the chemical equilibrium lab is that there are 3 different types of measurements that we make. We make one with a burette, one with a graduated cylinder, one with a volumetric pipette, and one with a transfer pipette. And each one of those pieces of equipment has a different level of accuracy that goes with it, and a level of precision that goes with it. So, and of course, some of them we use more than once. And each measurement that we make is going to have some finite amount of error in it. So making multiple measurements usually gives me more error than making a single. Those are things that I can look at in terms of what I've done and say, you know what, maybe next time I need to not do that to get better results. So what can I change if I need to go back to the lab and look at something else? Okay, so that's what we're talking about in terms of the scientific method. So again, think about what are things that might have gone wrong. I don't care if you get the wrong answer. Getting the wrong answer is never a big deal. Not being able to explain what might have happened, what are some reasonable things that might have gone wrong, how could you change things to make it better next time or to test it again, that's what I'm looking for. So that's the kind of thing that I'm looking for out of that. Now, I've had a couple of questions about the lab manual, and I understand that the lab manual I'm asking you to keep is probably a little bit different than what you were asked to keep in 110. We do step that up between 110 and 111. Part of that is because if you're taking 111, you're more likely to need to keep a lab notebook as you move into your career. So we need you to understand what are things that need to be done in that legal document. So all of the recommendations, that sample that you've been given has all of those things in it because they are expected. Do I expect you to do them perfect now? No, not at all. And what will happen is when you do them and you take pictures and you turn them into me, I will make comments on what you've done to say, this is great, this is not great, how come, let's fix this, let's fix that, that kind of stuff. It's not to be able to take points away from you. It's to show you what the expectation is for once you get out of here. And how do we get you there? So we're trying to get you there. I know you're not there yet, and that's okay. All right. So does anybody have any questions, comments, problems with any of the tips and tricks that we've talked about? If you do, please contact me. Email, phone, WebEx, any of that stuff. Please let me know. All right. I'm going to stop this video here and set us up for the next one. And we'll be talking about some periodic stuff. So the first 3 things we're going to be talking about in our review. Okay, see you soon.